Karl Fischer Moisture Titrator, MKC710. The MKC710 is widely used for determining the moisture content of various substances as a reliable moisture meter that has been adopted in many official analysis methods such as the ASTM, JIS, European Pharmacopoeia, and the United States Pharmacopoeia. By connecting up to 4 moisture titrators, measurements can be performed simultaneously in parallel and contribute to saving space. Not only can the Karl Fischer Moisture Titrator's coulommetric titration, MKC710B, and volumetric titration, MKV710B, be connected, but the automatic potentiometric titrator, AT710B, can also be connected as well. In moisture measurements via the coulommetric titration method, iodine is generated through the electrolysis of an analyte containing iodine ions. Notation 1. The consumption of the generated iodine is detected by the detection electrode, and electrolysis is carried out again. Notation 2. Iodine is generated according to the formula in Notation 2. The amount of generated iodine is proportional to the amount of electricity according to Faraday's law. Notation 1. From the above formula of Notation 1, I2 reacts with H2O at a ratio of 1:1. Based on the above principle, the electricity required for electrolysis is converted into moisture content. We will now give an explanation of the Karl Fischer Moisture Titrator, MKC710. The unpacking and checking of standard parts. The MKC710 unit, accessories, an instruction manual, etc. are included in the package. Please check that everything is present using the provided reference list. MKC710 Main Unit, MCU 710M, Magnetic Stirrer, Automatic Solvent Change Unit included, Automatic Solvent Change Unit, Titration Cell Unit, AC Adapter, Power cord, USB cable, DC plug cable, Operational Manual, CD-ROM, MKC710 Quick Reference, Inspection Certificate, Warranty, Contact, Packing List. The Karl Fischer Chem Aqua Series reagent is a reagent dedicated to the Karl Fischer Moisture Titrator, manufactured by Kyoto Electronics Manufacturing Company Limited. Individual part names and functions. We will now provide an explanation of the name and function of each part of MKC710. COM1 and COM2 connectors. A dot matrix printer can be used by connecting it to COM1. A moisture evaporator and multiple sample changer can be used by connecting them to COM2. USB connector. The MCU710 connects here. Stirrer connector, unit side. The magnetic stirrer that stirs the sample solution connects here. Power supply connector, in, out. The power cord connects here. Power switch. This switch turns the power supply of the device on and off. Inner burette connector. The inner burette plug connects here. The detection electrode plug connects here. Stirrer connector on the stirrer end. The stirrer cable connects between the backup stirrer and the main unit. Inner burette. Electrolysis occurs when the catalyte is injected and electricity runs between it and the analyte. Titration cell holder. This holds the titration cell. Detection electrode, twin platinum electrode. This electrode detects the electrical potential of the analyte. Assembling the titration cell. Put the stirrer rotor in the titration cell and attach the components of each part. Install the inner burette. The detection electrode. The desiccant tube. Remove the seal of the desiccant tube. Port plug 1925 PTPE. Port plug and the syringe inlet. Apply the grease lightly to the ground portion. Set the titration cell in the titration cell holder of the stirrer. Connect the inner burette and electrode cord plug of the detection electrode into the connectors and screw it in well. Assembling the automatic solvent change unit. Connect the bottle containing the Karl Fischer reagent analyte and the waste bottle to the solvent bottle cap and the waste bottle cap. Connect the silicone tube to both sides of the drawing desiccant tube. And attach the desiccant tube to the bottle stand. If the outer diameter of the reagent bottle does not fit in the bottle stand, use the bottle holder. Connect the silicone tube to the solvent bottle cap. Connect the drain tube on the waste bottle side and the injection tube to the waste bottle cap and solvent bottle cap respectively. Connect the connected silicone tube to solvent on the back of the magnetic stirrer. Connect the drain tube on the cell side and the injection tube to the plug for the cell. Connect the drain tube on waste bottle side and the drain tube on the cell side to the peristaltic pump on the back of the magnetic stirrer. Insert the plug for titration cell into the predetermined position of the titration cell lid so that the tubes do not break. Port plug and the syringe inlet. Remove the seal of the desiccant tube. Cable connections of cables. Make sure that the power switch is turned off. Attach the power cord to the AC adapter and connect the connector plug of the AC adapter to the power connector on the back of the main unit. Connect the stirrer cable to the stirrer and the main unit. Printer connection. Connecting a printer allows you to print titration results and method parameters. Load the paper. When the paper is cut on angle, it is easier to feed. Turn on the power switch. Analyte and catholyte injection. Add analyte and catholyte in the titration cell before the measurement. First, add the analyte into the titration cell. Press the injection on button and inject the analyte into the titration cell. For normal measurement, please use 100 milliliters of analyte. When it reaches the bottom line on the titration cell, you have 100 milliliters. When it reaches the bottom line, push the injection off button and stop the injection. Next, inject the catholyte. Prepare a glass ampule containing catholyte. Wrap the ampule with paper or cloth so that the pieces of glass don't be scattered. Support the ampule with your fingers on the white part and push the top section away to open the ampule. Draw up about 5 milliliters of catholyte with a pipette or syringe and inject it into the inner burette. Preparations for measurement. First, carry out the pre-titration. Please press pre-titration button will be displayed. Press the preliminary titration key. Pre-titration will begin. When the pre-titration is finished, wait until the drift value stabilizes. The wait till drift becomes stable display will change to drift stable. When the Please Press Start button appears, press Start button. Measurement will start. Measurement. Now enter the measurement. Draw the reagent into a syringe and weigh it with an electric balance. Press the Start button. Inject 1 milliliter of reagent into the titration cell. Press the sample button and weight 1. Enter the total weight before the injection of the reagent. Press the OK button and press the Exit button. Weigh the syringe with the electric balance again. Press the sample button and press the Weight 2 button. Enter the total weight after the injection of the reagent. Press the OK button and press the Exit button to return to the home screen. After the measurement is completed, the measurement result will be displayed. Options. Various options are available for the Karl Fischer Moisture Titrator MKC 710. Multiple Sample Changer CHK 501 Non-CE. Evaporator ADP 611. Evaporator for oil samples ADP 513. Evaporator for ore ADP 512. Evaporator for high temperature, ADP 512S. Multiple sample changer, CHK 501, non-CE. The multiple sample evaporator for the coulometric Karl Fischer moisture titrator is suitable for the continuous measurement of up to 24 samples. The heating temperature can be set for each sample individually, therefore different types of samples can be measured automatically one after the other. An auto power-off function after measurement ensures safe operation. Evaporator, ADP 611. This evaporator allows for the measurement of the moisture content in powders or solid samples that cause side reactions and therefore cannot be titrated directly. Heat the sample and bubble the evaporated water vapor in the cell for measurement. The sample boat maneuvers in airtight conditions by magnetic control, eliminating the effects of moisture in the atmosphere, thus allowing reliable measurements to be made for minute traces of water. Scan mode for optimal evaporation is used to determine the evaporation temperature of a sample when it is unknown or to check the temperature behavior of the reagent. Heat the sample and bubble the evaporated water vapor in the cell for measurement. Evaporator for oil sample, ADP 513, non-CE. Used for determining the moisture content of ASTM D6304, standard test method for determination of water and petroleum products. Lubricating oils and additives by coulometric Karl Fischer titration. An apparatus that evaporates the moisture content that is present in samples dissolved in a heated base oil. This unit is primarily used for the moisture measurements of lubricant oils, grease, tar products, paints, and other viscous liquids. This time, we will briefly show you how to use the evaporator for oil sample, ADP 513. First, press Method button. Press the Edit button and press the Titration Parameter button. Press the Wait button and enter the shortest time length for a measurement from start to end. Press the OK button to return. Press the Max button and set the titration time limit. Press the OK button to return. Press the Home button to return to the home screen. Draw the reagent into a syringe and weigh it with an electric balance. Press the Start button. Inject 1 milliliter of reagent into the titration cell. Press the Sample button and wait 1. Enter the total weight before the injection of the reagent. Press the OK button and press the Exit button. Weigh the syringe with the electric balance again. Press the Sample button and press Wait 2 button. Enter the total weight after the injection of the reagent. And press the Exit button to return to the home screen. the measurement is complete, the measurement result will be displayed. This is the basic process for using the evaporator for oil sample. ADP 513. Karl Fischer Moisture Titrator, MKC 710. The MKC 710 is widely used for determining the moisture content of various substances as a reliable moisture meter that has been adopted in many official analysis methods such as the ASTM, JIS, European Pharmacopoeia, and the United States Pharmacopoeia. By connecting up to 4 moisture titrators, measurements can be performed simultaneously in parallel and contribute to saving space.